Our lesson number 2 is all about maintaining kitchen tools, equipment, and working area. Let's start with cleaning and sanitizing. Cleaning and sanitizing procedures must be part of the standard operating procedures that make up your food safety program. Improperly cleaned and sanitized surfaces allow harmful microorganisms to be transferred from one food to other foods. Cleaning. What is cleaning? It is the process of removing food and other types of soil from a surface, such as a dish, glass, or cutting board. Cleaning is done with a cleaning agent that removes food, soil, or other substances. The right cleaning agent must be selected because not all cleaning agents can be used on food contact surfaces. A food contact surfaces is the surface of equipment or utensils that food normally comes into contact. For example, glass cleaners. Some metal cleaners and most bathroom cleaners cannot be used because they might leave an unsafe residue on the food contact surface. The label should indicate if the product can be used on a food contact surface. The right cleaning agent must also be selected to make cleaning easy. Now let us identify first the areas to be cleaned. We have workspace like benches and shelving, and also we have storage space for food and chemical storage. And also we have outside of the premises where the garbage is stored. And also the walls. All walls get dirty from impurities in the air. And also the ceiling. Ceilings get dirty from impurities in the air also. And also, of course, the floors. If the floors were not cleaned, soon we can touch the ceiling. And also the fittings. Impurities from the air settle in form of dust and grease. Now let's go to cleaning agents. These are divided into 4 categories. First, we have detergents. Use detergents to routinely wash tableware, surfaces, and equipment. Detergents can penetrate soil quickly and soften it. Examples include dishwashing detergent and automatic dishwasher detergents. And also we have solvent cleaners, used periodically on surfaces where grease has burned on. Solvent cleaners are often called degreasers. And also we have acid cleaners, used periodically on mineral deposits and other soils that detergents cannot remove. These cleaners are often used to remove scale in ware, washing machines, and steam tables. And also we have abrasive cleaners. Use these cleaners to remove heavy accumulations of soil that are difficult to remove with detergents. Some abrasive cleaners also disinfect. Clean food contact surfaces that are used to prepare potentially hazardous foods as needed throughout the day, but not less than every 4 hours. If they are not properly cleaned, food that comes into contact with these surfaces could become contaminated. Now let's go to sanitizing. As you can see on top, we have Ultimate Guide to Manual Ware Washing. So what is sanitizing? Sanitizing is done using heat, radiation, or chemicals. Heat and chemicals are commonly used as a method for sanitizing in a restaurant. Radiation rarely is. The item to be sanitized must first be washed properly before it can be properly sanitized. Some chemical sanitizers, such as chlorine and iodine, react with food and soil and so will be less effective on a surface that has not been properly cleaned. We have mentioned earlier that we have three sanitizing methods: heat, radiation, and chemicals. Now let's start with the heat. There are three methods of using heat to sanitize surfaces: steam, hot water, and hot air. Hot water is the most common method used in many restaurants. If hot water is used in the third compartment of a three-compartment sink, it must be at least 171 degrees Fahrenheit. If a high-temperature washing machine is used to sanitize clean dishes, the final sanitizing rinse must be at least 180 degrees Fahrenheit. For stationary rack single-temperature machines, it must be at least 165 degrees Fahrenheit. Cleaned items must be exposed to these temperatures for at least 30 seconds. Now let's go to chemicals. Chemicals that are approved sanitizers are chlorine, iodine, and quaternary ammonium. Different factors influence the effectiveness of chemical sanitizers. We have three factors that must be considered. First, its concentration. The presence of too little sanitizer will result in an inadequate reduction of harmful microorganisms. Too much can be toxic. And also we have to consider also the temperature. Generally, chemical sanitizers work best in water that is between 55 degrees Fahrenheit and 120 degrees Fahrenheit. And also we have to consider its contact time. In order for the sanitizer to kill harmful microorganisms, the clean item must be in contact with the sanitizer, either heat or approved chemicals, for the recommended length of time. Now let's go to the other method of sanitizing, which is radiation. There are two general types of radiation used for sterilization: ionizing radiation and non-ionizing radiation. Ionizing radiation is the use of short-wavelength, high-intensity radiation to destroy microorganisms. This radiation can come in the form of gamma or X-rays that react with DNA, resulting in a damaged cell. Non-ionizing radiation uses longer wavelength and lower energy. As a result, non-ionizing radiation loses the ability to penetrate substances and can only be used for sterilizing surfaces. The most common form of non-ionizing radiation is ultraviolet light, which is used in a variety of manners throughout industry. One industrial application of non-ionizing radiation is the breakdown of ozone. By adding ozone to water, bacteria are unable to sustain life. Unfortunately, ozone also destroys processed media. Therefore, ozone must be broken down so water can be used for its designated purpose. Since ozone is very sensitive to ultraviolet light, past the water stream under UV valves. This breaks the oxygen-to-oxygen bonds and results in safe processed water. Here is a simple representation of the system. As you can see at the photo on top, that is the representation of how the radiation works. First, we ozonated the water, passed through the UV light, and then we have deozonated water. Now, what are the advantages? No degradation of media during sterilization, thus it can be used for thermally labile media, and also leaves no chemical residue, and also administration of precise dosage and uniform dosage distribution, and also immediate availability of the media after sterilization. While these advantages, this method is a more costly alternative to heat sterilization, requires highly specialized equipment. In sanitizing, it is also important that we do sanitizer testing. Every restaurant must have the appropriate testing kit to measure chemical sanitizer concentrations to accurately test the strength of a sanitizing solution. One must first determine which chemical is being used: chlorine, iodine, or quaternary ammonium. Test kits are not interchangeable, so check with your chemical supplier to be certain that you are using the correct kit. The appropriate test kit must then be used throughout the day to measure chemical sanitizer concentrations. Now let's go to advantages and disadvantages of different chemical sanitizers. First, we have chlorine. Its appropriate concentration will be 50 parts per milliliter in water between 75 and 100 degrees Fahrenheit. Its appropriate contact time will be 7 seconds. Its advantages: effective on a wide variety of bacteria, highly effective, not affected by hard water, generally inexpensive. While its disadvantages: corrosive, irritating to the skin, effectiveness decreases with increasing pH of solution, deteriorates during storage and when exposed to light, dissipates rapidly, loses activity in the presence of organic water. Let's go to iodine. Its appropriate concentration will be 12.5 to 25 parts per milliliter in water, that is at least 75 degrees Fahrenheit. Its contact time will be 30 seconds. Its advantages: forms brown color that indicates strength, not affected by hard water, less irritating to the skin than is chlorine, and activity not lost rapidly in the presence of organic matter. Its disadvantages: effectiveness decreases greatly with an increase in pH, most active at pH 3.0. Very low acting at pH 7.0. Should not be used in water that is at 120 degrees Fahrenheit or hotter, and might discolor equipment and surfaces. Now let's go to quaternary ammonium compounds. Its concentration will be 200 parts per milliliter in water that is at least 75 degrees Fahrenheit. Its contact time will be 30 seconds. Its advantages: non-toxic, odorless, colorless, non-corrosive, non-irritating, stable to heat, and relatively stable in the presence of organic matter. Active over a wide pH range. Its disadvantages: slow destruction of some microorganisms, not compatible with some detergents, and hard water. As a review, on a sheet of paper, complete the incomplete statements. First, I've learned that. Second, I've discovered that. Third, I realized that. It's sharing time. For your activity number 1, direction. Answer the following questions in a clean sheet of paper. Number 1, why it is important to clean, sanitize, and store equipment properly. Number 2, enumerate ways on the proper storage of cleaning equipment. Now let's go to your activity number 2. Actual practice of cleaning. Direction. Observe how your family clean and sanitize the kitchen tools and equipment in your own home. Take note of your observations and make comments, suggestions on how to improve their methods of cleaning and sanitizing kitchen tools and equipment. Write it down on a sheet of paper.